We need to determine the equation of a circle having a radius of 5 units and the circle is tangent to both the x and the y axis. So let's try to first understand the problem. So we'll use a Cartesian plane. We have here the familiar x and the y axis. Now let's try to imagine a circle which has a radius of 5 and is tangent to both the x and the y axis. So the circle is going to touch the y axis as well as the x-axis, and the circle is going to have a radius of 5 units. So this is one of the scenario. Now we can have 3 other circles so that can also touch the x-axis as well as the y-axis. So we can have a circle on the second quadrant, then we can have the third circle on the third quadrant. This circle also touches the x as well as the y-axis, and then we have one more circle on the fourth quadrant which is also going to have a radius of 5 units and touches both the x and the y-axis. Now all these circles have a radius of 5 units. So that means we'll need to find out the equation of each of the 4 circles. Now let us begin. To find out the equation, what we'll do, we'll take the help of the standard form of a circle. So here, if we have a circle having a center coordinate x, h, comma, k, and a radius of r, then the standard form of the circle is given by this particular formula, which is x minus h whole squared plus y minus k whole squared equals to the square of the radius. Now since we have 4 circles, we'll start with our first circle in the first quadrant. Now let's start with the first circle. Now here, we will need the coordinate of the center as well as the radius. We already have the radius that's given to us. Now what do you think will be the coordinate of the center? Now clearly, let's say from the origin, if we drop a perpendicular on the x-axis, so this height is going to give us the y coordinate of the center, and this is also the radius of the circle. Similarly, we need the x coordinate. So from the center, we are going to drop another perpendicular on the y-axis. Now this distance to the perpendicular, the distance of the perpendicular from the origin to the y-axis gives us the y coordinate, and this incidentally is also the radius of the circle. That means the coordinate of the center is 5, 5. So now we have a center. So the center is, which is given by h, k. So we found out that this is 5, 5. This immediately tells us that the value of h is going to be 5 units and the value of k is going to be 5 units, and the radius is also going to be 5 units. And that means we can use the standard form, and that gives us x minus h. So h value is 5. We have x minus 5 whole squared plus y minus 5 whole squared, and this is going to be equals to 5 squared. This is the standard form of the circle. However, what we can do, we can further expand this, and which I'll be leaving as an exercise for you to try out. Now we'll come to the second circle, the circle lying in region number 2. Now what will be the center of this particular circle? Now here, same rule. What we'll do, we will drop a perpendicular on both the x-axis as well as the y-axis, and that's going to give us the coordinate of the center. Now here, the height is going to be 5, so that means the y coordinate is going to be 5 and the x coordinate is going to be negative 5 because we're lying on the negative x-axis. Now that means we have here the center h, k. So that's going to be equals to negative 5, 5. That tells us the value of h. So h is going to be negative 5, k is going to be positive 5, and the radius is still going to be 5 units, meaning the equation of the circle is going to be x minus of minus 5. So this means this will become positive 5. So x plus 5 whole squared plus y minus 5 whole squared, and this will be equals to 5 squared. Now coming to the third circle, so what's the center? So the center coordinate is going to be negative 5, negative 5. That's because we are in the third quadrant. In the third quadrant, both the x coordinate as well as the y coordinate is negative. So the equation of the circle is going to be x minus 5. So with the x plus 5 whole squared plus y plus 5 whole squared, and that's equals to 5 squared. Coming to the fourth quadrant, the fourth circle, what do you think will be the coordinate of the center? Yes, so x coordinate is going to be positive 5, but the y coordinate is going to be negative 5. So our equation is then going to be x minus 5 whole squared plus y minus of minus 5, so we get positive 5 whole square, and this is going to be equals to 5 square. So these are the 4 equations of the circles, and each of the circle has a radius of 5 units and touches both the x-axis as well as the y-axis.